We're going to take a trip back to arithmetic and geometric series that we looked at last year, but now more specifically just applications of them. Here's a, well, reasonably old question now. Heather is going to go for a swim every day to improve her fitness level. Very commendable. On the first day mind you, someone wants to improve their fitness level. On the first day, I think I'll swim 750 metres. That's only 15 laps of the pool. Because, you know, when you're not fit and you want to improve your fitness level, you go and do 15 laps of a... Anyway, I love realistic questions. And on each day after that, she says, you know what, I'm going to add 100 metres more than the previous day. Just in case you can't work out what that means, she'll then go and swim 850 metres on the second day, then 950 metres on the third day, and so on and so on. Write down a formula for the distance she goes and swims on the nth day. I think there's a T missing. On the nth day. All right, first term, 750. Common difference, 100. We know the general term, a plus n minus 1d. Sub in, play around with it. There's our formula, 650 plus 100n. Well, how far does she swim on the 10th day? Let's make n equal 10. 1,650 metres. What's the total distance? If you add up total distance over the 10 days, so now we use our sum to n formula. I've used this one, n on 2, 2a plus n minus 1d, subbing in the info that we know, 12,000 metres. But of course, in this situation, we have an alternative formula we could have used. N on 2, a plus l, because we know what the last term is, we just worked it out, sub it in, and surprise, surprise, we get exactly the same answer. Well, just out of curiosity, because these are the sorts of things you want to know in the real world. After how many days does the total distance she swum equal the width of the English Channel? That's 34 kilometres. Okay, there's my sum to n formula. We want to know when that is equal to 34,000. What is n? So basically we end up with a quadratic equation. There it is. Well, we can make that easier. Everything divides by 100. What multiplies together to give minus 680 and adds together to give 14. Yes, I'm sure you came up with this straight away as well. N plus 32, N minus 20. So we have two possibilities. N equals negative 34 or N equals 20. But of course, in the context of our question, only one of those makes sense. I mean, you can't say, oh, that happened 34 days ago. So it must be the one that says, oh, it takes 20 days to swim. Company sales are declining by 6% every year. 50,000 items are sold in 2001. During which year will sales first fall below 20,000? Well, first term, 50,000. We're talking about a geometric one this time, so the common ratio. Now, this is where we've got to be careful, because decline by 6% means the ratio is 0.94, because we just get 94% each time. We want to know when is the general term less than 20,000. So let's create the general term. AR to the n minus 1. We want 20,000 to be greater than 50,000 times 0.94 to n minus 1. Divide both sides by 50,000. We've got an exponential equation, or inequation in this case. So we log both sides. But that allows me to bring the n minus 1 out the front. We now divide by the log, but of course log of a number smaller than 1 is a negative number. So when we change the sign, we change the sign. So n minus 1 will be greater than log 0.4 over log 0.94, greater than 14.8, and so on. We're looking for whole numbers in the context of this question. First whole number bigger than that is 15. Oh, no, it's not, because we've got to add 1 to both sides. First whole number bigger than that is 16. So 16th year, 2016, sales fall below. Here's a 2005 HSC. Anne and Kay are employed by an accounting firm, and they accepted some really weird conditions of employment. What Anne says is, oh, look, okay, yes, I'll take this initial salary of $50,000, but in every year, I want you to increase it by $2,500. Okay. Kay also accepts employment and starts off with $50,000, but she says, no, I want you just to increase my salary by 4% every year. Let's work it out. Well, arithmetic, the first one's arithmetic. First term 50,000 and the difference 2,500. Whereas the second one, K, is geometric. This time increasing by 4%, so the ratio is 1.04 that we're going to be playing with. What's Anne's salary after 13 years? Again, we're just subbing into our general term. So A plus N minus 1D, sub it in, bit of calculator work, $80,000. Well, what about K? Did she do better? Geometric. Sub in. Oh, just. After 13 years, she's $51 ahead. So $80,051.61. So by what amount does the total amount paid to K in the first 20 years exceed Anne's one? Right, we're now using the sum formula. So for Anne, we end up with $1,475,000. K, geometric. Oh yeah, look at that one. $1,488,000. So the difference, $13,903.93 after 20 years. Okay, I suppose this is not really an application, but it's still an interesting question. Explain why the geometric series, this one here, does not have a limiting sum. That comes down to remembering what the condition is to have a limiting sum. Well, first of all, it's got to be geometric. But it's something about the ratio, if you recall. The ratio has to be in between -1 and 1. So what is our ratio? 1 on the square root of 2 minus 1, which is, well, there you go, 2.414. So that's bigger than 1. So that's why, no limiting sum. This brings up this question, which came from an HSC. Similar sort of question, but a little bit more involved. Here's the series. 1 minus tan squared plus tan to the power of 4. When the limiting sum exists, because depending on what theta is, sometimes it will exist, sometimes it won't exist. So when it does exist, find its value in simplest form. Well, when it does exist, well, it doesn't matter when it doesn't exist, A is going to be what? The ratio is minus tan squared theta. As I say, sometimes that will be bigger than 1, sometimes that will be smaller than 1. So sum to infinity, A on 1 minus R. So when it exists, we get 1 on 1 plus tan squared, but of course, 1 plus tan squared is sec squared, and the reciprocal of sec squared is cos squared. All right then, so between minus pi and 2 and pi and 2, so that would be the two asymptotes about the origin of our tan curve. What values will our limiting sum actually exist? So again, we know it's going to happen in between -1 and 1. We're saying, when does minus tan squared theta be in between -1 and 1? Well, divide by -1, if you change the sign, you change the sign, you actually still end up with tan squared theta in between -1 and 1. So we want to know, when is tan theta in between -1 and 1? Well, we know it's equal to 1 at pi on 4, or 45 degrees. It's probably easy just to look at the graph to get our heads around it. There's the tan curve. We're saying that in between minus pi on 4 and pi on 4 there, so we want less than, so yeah, it's in between the two, not on the outside of the two. So looking at the graph, we go, okay, when theta's in between minus pi on 4 and pi on 4, that's when the limiting sum will exist. Okay.